Okay, so this is the last video on electrolysis, and it's about the purification of copper, which is a core practical. We've seen in previous videos that we use electrolysis to extract metals from compounds. In this video, however, we're going to look at a slightly different application for electrolysis. We're going to look at the use of electrolysis to purify copper. The reason it's important that we purify copper is very useful. It's a great conductor of electricity, and we use it in electrical wires. Because we need lots of copper, it's important that we have techniques to purify it. So as I said, we're going to use electrolysis to purify copper. So because it's electrolysis, we're going to be using electricity. So I'm going to start by drawing out my battery, which is the power source in electrolysis. It's going to provide my electricity. The positive end of the battery is going to be connected to the anode. So the anode is my positive electrode, and the negative end of the battery is going to be connected to my cathode. In the previous videos, we've looked at what substances we typically use for the anode and the cathode. And we've seen that we use inert materials, so unreactive materials, and we typically use the unreactive metal platinum, or else we use graphite. In this experiment, the purification of copper, at the anode, we are actually going to place impure copper. So we're not going to be using graphite, we're not going to be using platinum, we're actually going to use impure copper. So you're going to have a piece of metal that contains lots of copper, but it's also got impurity, so it's impure copper. And we're going to look at what happens to the impure copper at the anode when you turn the power on. I'm going to write here what happens at the anode. So again, from previous videos, we should know that at the anode, oxidation occurs. Oxidation occurs, and oxidation is the loss of electrons. In your impure copper, you have got copper atoms. Those copper atoms, symbol for copper is Cu, the copper atoms are going to lose electrons. And again, the reason they're going to lose electrons is because they're connected to the anode, and at the anode, oxidation is going to occur. So Cu atoms are going to lose electrons. In copper, you're typically losing 2 electrons. Okay, so copper is a transition metal. It's not in one of the main groups. It can lose 1, it can lose 2. In this case, we're just going to say it's losing 2 electrons. And when copper loses 2 electrons, it forms a Cu plus 2 ion. So metals always lose electrons. They always become positively charged. So all of your copper atoms in your impure copper are going to lose their electrons because they're connected to the anode, and oxidation occurs. When they lose their electrons, they are going to form Cu plus 2 ions. So at the start, before you turned the electricity on, your copper atoms were not charged. When you turn on the power and they lose their electrons, they form Cu plus 2 ions. When they become charged, they are going to move. Your Cu plus 2 ions, when they are formed, are all going to be attracted to the cathode. Okay, so your Cu plus 2 ions are going to be attracted to the cathode. So all of your copper atoms become copper ions. Once they become ions, they move to the cathode. What about the impurities that were present in the anode? We said this was impure copper, so you don't just have copper here at the electrode, you've got other impurities. Okay, your impurities are not going to form ions. And what's going to happen is all of your impurities will just collect below the anode, and we call it sludge. So this is sludge. And all of the impurities, they don't form ions, and they just deteriorate and form sludge at the bottom of the anode. Overall, because your impurities are just dropping down to the bottom as sludge, and because your copper atoms are becoming ions and moving to the cathode, overall, your anode is going to lose mass. So let's say, for example, that our impure piece of copper that we connected to the anode, let's say it started off with a mass of 100 grams. From that piece of impure copper, your copper atoms become ions and move. Your impurities become sludge and fall to the bottom. So you're going to end up losing mass. Let's just say we lost 20 grams over the course of the experiment, and you end up with a smaller mass at the anode at the end. So that's the anode. Now we need to look at the cathode. So we said that your copper ions are all going to move to the cathode. So what exactly am I using at the cathode? Now you may think that I'm using something like graphite, which we've used before. But if I used graphite at the cathode, all of my copper ions would move to the cathode, and I would end up with a piece of graphite coated in copper. Remember, the objective here is to get pure copper, so copper with nothing else present. If I started off with a piece of graphite, I'm going to end up with a piece of graphite coated in copper. That's not pure copper. So what I'm actually going to have at the cathode is just pure copper. I'm going to need to have a piece of pure copper. And then what I'm going to be doing is I'm going to be adding to that piece of pure copper, adding more and more copper to my piece of pure copper. So at the end of the experiment, I've got a greater mass of pure copper than what I started with. So if we look at the cathode, we need to look at what's happening in terms of electron at the cathode. So we just said oxidation occurs at the anode. That must mean a reduction is occurring at the cathode. And if oxidation is loss, then reduction is gain of the electrons. So what's going to happen is we've seen that the Cu+2 ions are all attracted to the cathode. The Cu+2 ions are going to gain electrons at the cathode. I can write that as a half equation. So Cu+2, they've lost 2 electrons, so they gain 2 electrons, and they form Cu atoms again. So when your ions migrate to the cathode, they become atoms again, and they're going to build up as solid copper all around the cathode. Your cathode is going to gain mass. So let's just say that it started off at 100 grams as well, and it gained 15 grams of copper, and it ends up at 115. Notice that I didn't add the same amount that I lost from the anode. Some of the mass of the anode is lost as sludge, so it's not just all copper losing, so it's not just the anode losing copper, it's also losing some impurities. So let's just say out of the 20 grams that the anode lost, 15 grams of that was copper, so that's going to add on to the mass of the cathode, but let's just say the other 5 grams was impurities, which formed at the bottom of sludge. So your anode is losing mass, your cathode is gaining mass. In order for this to work, we've seen this before, in order for this to work, you need some sort of ionic compound. You need an electrolyte for the electricity to flow through. So I can't just have these pieces of copper just floating in midair. There needs to be something for the electricity to flow through. And we know that ionic compounds do conduct electricity when they're molten or when they're aqueous. If I were to use, let's say, NaCl molten, okay, let's just say I was using NaCl molten as my electrolyte so that the electricity could flow through, what I would have then is I would have lots of sodium ions, and all of those sodium ions would also move to the cathode. I'm trying to get pure copper at the cathode, so I don't want any other metal ions in my electrolyte. So I'm not going to be using sodium, I'm not going to be using potassium, I'm not going to be using any other metal. My electrolyte has got to contain copper. And typically what we use is we use copper sulfate aqueous. Okay? If you've got copper sulfate aqueous, then you've got copper ions in your electrolyte, and again, those copper ions will then move to the cathode. Those copper ions at the cathode will be converted back to copper atoms, and again, the copper sulfate that you use as your electrolyte will contribute even more pure copper to your cathode. So you have to use an electrolyte that contains copper. I've got some typical questions here. You can be asked why the anode loses mass in the purification. Okay, it's losing mass because all of the copper atoms in the anode become ions. Remember, oxidation occurs at the anode, so they lose their electrons, they become ions, and once they form ions, they're gonna move to the cathode. So you get all of these ions leaving the anode for the cathode. The anode loses mass. You're also gonna have all of the impurities in the anode collecting at the bottom as sludge. You can be asked why the cathode gains mass. Again, this is going to be similar. So the copper atoms that you had in the anode, they all become positively charged ions, and those positive ions move to the cathode. You could also say that the copper from the electrolyte, from your copper sulfate, they also move to the cathode. So overall, the cathode is going to be gaining mass because of all of these copper ions that are being attracted to the cathode and then being converted back into atoms again. Why do you use copper sulfate? You want to use copper sulfate so that copper is forming at the cathode. You don't want some other metal also forming at the cathode. The whole aim is to produce pure copper. So I want you to try some questions for me. I've got the 10 questions in section A and 6 in section B. So section A is more kind of simple 1-mark answers. Section B involves writing some half equations. So please press pause, answer all of these questions, take your time to do it properly, press play when you're ready to see the answers. Okay, so we'll go through the answers. Substance typically used as electrodes is going to be graphite and platinum. And the criteria a substance must meet is they must have a high melting point. Don't say boiling point, it's high melting point. They must be inert, so they're not reactive, and they must conduct electricity. However, in the purification of copper, we're going to be using copper. Impure copper at one electrode, pure copper at the other. Your electrolyte is going to be copper sulfate solution. Make sure you're not just writing copper sulfate, it should be a solution. Or you could say molten, to be fair. Which electrode contains the pure copper? You attach the pure copper to the cathode. Remember, metals become positively charged ions. Metal ions move to the cathode. You want your pure copper at the cathode because that's where the other copper ions are going to go. Because all of the copper ions move there, the cathode gains mass. You attach your impure copper to the anode, and because your copper atoms become ions and move, the anode loses mass. The impurities, they form sludge below the anode, and you keep the sludge because it can contain expensive metals, such as something like gold, really unreactive metals that don't form ions, they just collect at the bottom as sludge. For B, it's the same answer as I had here, so this is why the anode loses mass. The atoms becomes positively charged ions, then they move to the cathode. The impurities also form sludge, so you're losing the impurities and you're losing the copper. The anode is going to lose mass. Oxidation and reduction. At the anode, it's going to be oxidation, and a half equation to show that. If they're telling you they want you to form Cu plus 2 ions, plus 2 means it's lost 2 electrons. So I start off with my copper, I lose 2 electrons, I form Cu plus 2 ions. How does the cathode gain mass? That's going to be here. Okay, the copper atoms in the anode become positively charged ions. Those ions move to the cathode. You could also say that the copper ions from the electrolyte move to the cathode, and both will cause the cathode to gain mass. It's a reduction that is occurring at the cathode. A half equation would be the Cu plus 2 ions arrive at the cathode. They gain back the 2 electrons that they lost, and they form copper metal again. This copper, if I were to add state symbols, the ions are aqueous, so they're dissolved in solution, but when it forms copper metal, that's going to be a solid. So there's a solid that's going to build up around the cathode again. That's why your cathode is going to increase in mass.